Hey everyone, welcome to lesson 2 of theme 3 GCSE geography. So today we're going to look at destructive plate boundaries or plate margins. Remember, they might use the two words interchangeably, and their features. So we're going to explain the processes happening at a destructive plate boundary and then identify and explain the main hazards and features, the things that a destructive boundary makes. So essentially all we're doing is looking at a part of the convection current diagram that we drew for the Earth's interior last lesson, where the convection currents move towards each other. It pulls the crust on top towards itself, and the two plates crash into each other, and it destroys crust. That's why it's called a destructive plate boundary. So pause the video here a moment. Apologies, someone's cutting the grass right outside. I've shut the windows. I don't know how much background noise it's going to create. We'll just have to roll with it. Pause the video here a minute, go ahead and write down the title, and we'll get started. Okay, so first up, what does it look like? Let's take a look. So here's a diagram of a destructive plate margin or boundary. As you can see, oceanic crust is being destroyed. It's going down and melting in the mantle. So what happens here, where oceanic crust and continental crust meet, they're forced towards each other because the convection current in the mantle here is going this way, and the convection current in the mantle here is going this way. Now the problem is, these two pieces of crust, these two tectonic plates, are different densities. Oceanic crust is more dense. And what it means is when they crash into each other, the oceanic crust is forced downwards. This is called subduction. And then slab pull will kick in down here and drag it quickly down into the mantle. When I say quickly, mind, we're still only talking 2 to 6 centimetres rate of movement a year, but relatively quickly for a tectonic plate. So we've got subduction happening here. Now then, that subduction causes friction on the edge of the continental plate as well, the edge of the piece of continental crust. So it drags the edge of the continental crust down a bit. What that creates, the subduction and the dragging, creates what's called an ocean trench. You might have heard of the Mariana Trench. These are tens of kilometres deep, and it's what was referred to on the video last lesson on Google Earth that you see sometimes, the like dark lines along the edge of continents. That's what's happening, is subduction and friction dragging that edge down to create an ocean trench. What then happens as this oceanic crust is subducted into the mantle? Obviously it's 3000 degrees centigrade down here. So this oceanic crust melts and creates extra magma. What does hot liquid want to do? It wants to rise. So this hot liquid rises and burns through the continental crust, creating volcanoes along the edge. You also get a chain of what's called fold mountains. As the continental crust continues to try to come this way, but it's crashing into the oceanic crust, this pressure causes the edge of the continent to buckle upwards to form mountains. They're called fold mountains because it's like the land is literally folding up on itself due to the pressure. It's like buckling upwards. And it's within this chain of fold mountains that you get scattered volcanoes because of this melting magma from the oceanic crust. Now then, you've got a sheet that goes with this lesson. It looks like this. I'm hoping you're able to print it nice and big on A3 paper. Now I know A3 capability printing at home is actually probably quite rare. So you're welcome to instead just put these subheadings in your book, okay? And I can always give you this picture when we come back in after isolation or when you're next back in school. So we can work in subheadings if you prefer. So if you're able to use the sheet, great, write straight on the sheet. If not, put a subheading, how do destructive plate boundaries work? And we are going to make an explanation of what's going on. Now to start with, I'd jumbled up a load of statements and I wanted you to sort them yourself, but then I felt a little bit bad for you. It was actually a little bit tricky. So I've unjumbled them for you into 4 statements. So a destructive margin or boundary happens where oceanic crust meets continental crust. So you've got these two pieces of plate. Tectonic plate. The oceanic crust is forced downwards by slab pull because it's more dense. That's called subduction. As the oceanic crust continues to sink, the friction drags the edge of the continental plate downwards a little, creating an ocean trench. And the subduction of the oceanic, the subducting oceanic crust melts in the mantle and rises to the surface to form volcanoes. And the pressure of the plates colliding causes the land on the edge of the continental plate to buckle upwards to form fold mountains. So the main features at a destructive boundary are an ocean trench, volcanoes, fold mountains, and lastly, volcanic island arcs. These are a bit more complicated and we'll look at them later on. So in that first box, can you write down, you can reword it or summarise it further if you like, but put down some sort of version of these 4 statements. Bullet points is fine. Okay, so the next thing we're going to do is talk about the hazards that go with, that are associated with a destructive plate boundary. Destructive plate boundaries are the most dangerous type of boundary. You get all 3 hazards here: earthquakes, volcanoes, and tsunamis. Because what's happening is all this pressure building up here where the 2 plates are forcing towards each other, that pressure builds up and creates a lot of earthquakes. Additionally, where this edge is buckling downwards, eventually that pressure will become too great and it sort of flips back upwards to try and become level again. And that creates a huge underwater earthquake all the way along the trench, or for a section of the trench. And as that flips upwards and the earthquake happens under the ocean, it pushes all of the water above it. And that's what creates a tsunami, and that will radiate, it will spread out in all directions. And you also get volcanoes because the subducting oceanic crust melts in the mantle, making more magma to create volcanic eruptions. The volcanoes here tend to be what we call stratovolcanoes, and their eruptions tend to be particularly explosive because there's often moisture trapped and brought down here. And when it's superheated at high temperatures, that moisture goes through a process called flashing, which is a really quick sort of boiling expansion process that makes the lava extra explosive and creates something called pyroclastic flows as well. And we'll talk more about that when we go on to volcanoes. But what we're going to do now is fill in this part of your sheet, or put a subheading, what hazards are associated with destructive boundaries, and we're going to write 3 parts for each of these hazards. So if we go back to the PowerPoint, so current slide, volcanoes. Anything along these lines you should write into that gap. Volcanoes are created where the subducting oceanic crust melts in the mantle to create extra magma. The magma then rises and burns through the continental crust to create a volcanic eruption. We'll deal with the structure of volcanoes more later on. If you want to make a little diagram of this in your books as an extra, by all means go ahead, but we will deal with volcanoes more specifically later on. Re-listen to the first part of what I've just said, how a destructive boundary creates a volcano, and in your own words write a sentence or 2 to explain it on your sheet or in your book. Okay, the next one, earthquakes. So here's a simplified diagram of a destructive boundary. Anything along these lines, write it down for how a destructive boundary creates an earthquake. As the oceanic crust is subducted, the friction of it moving past the edge of the continental crust can build up to create earthquakes along the plate boundary. And finally, for tsunamis, it kind of links to earthquakes, okay? So for a tsunami, what happens is the subducting oceanic crust drags the edge of the continental crust down a little. Eventually, the pressure becomes too much, and the edge of the continental crust thrusts or flips back upwards, creating an underwater earthquake. This movement pushes the ocean above the boundary, creating a tsunami wave that then radiates. It ripples out in all directions across the ocean. We're talking speeds as fast as a jet plane, and sometimes as high as a 6-story building. These really are impressive. So pause the video here a moment, re-listen if you need to, and write some sentences on how a destructive boundary creates volcanic eruptions, earthquakes, and tsunamis. Okay, so just to cement your understanding of tsunamis, there's a little video here that you can watch. Okay, so hopefully that's helped a little bit cement your understanding of tsunamis. So far we've talked about how the destructive boundary works, how it creates hazards, volcanic eruptions, earthquakes, and tsunamis. Now we're going to break down a little bit how it creates each of the features we were talking about: an ocean trench, a volcanic island arc, and fold mountains. So on your sheet, it's these bottom boxes we're going to work through now. Okay, ocean trenches, fold mountains, and volcanic island arcs. All right, so if we go from an ocean trench first, these are really long. They tend to run along most of the boundary between the two plates. And they're quite narrow and they can be very, very deep. And they're formed where the oceanic crust is subducting underneath the continental crust, and it drags the edge of the continental crust down slightly. They can vary in depth between 6 to 11 kilometers deep, sometimes thousands of kilometers long, and often not very wide, like I said, about 70 kilometers wide. Some of the most famous examples are the Mariana Trench and the Atacama Trench. You can see here on a screenshot from Google Earth, it's visible from space. It's that deep and that marked. The South American plate is coming this way, continental. The Pacific plate is sort of going in that direction, oceanic. So the Pacific plate is subducting underneath the edge of the continental South American plate, and you get the ocean trench forming. And you have really interesting creatures living down there. It's so dark and at such high pressure. Some of these trenches, we haven't even been to the bottom of them yet. We don't know what's down there. We haven't got the machinery that can withstand the pressure yet. So there's all kinds of animals down there that are either blind because it's so dark, you don't need the light, you don't need vision because you can't see anyway, or they create their own light using bioluminescence. Some of the sea creatures literally light up by mixing enzymes in their body. It's very clever. So pause the video here a moment, put any kind of summarised version of that down in the bottom left-hand box to explain how ocean trenches form. Okay, next feature. Fold mountains. They are mountains literally created by the folding and buckling up of the continent on the edge of the boundary. So South America as an example again, the Andes Mountains. What's happening here is the continent is trying to come this way because the piece of crust, the plate that it sits on, is going this way, but it's crashing into the Pacific plate here, and the pressure causes the edge of the land to buckle upwards. All right. So you've got the Andes Mountains down here. Another example is the Himalayas, where India is crashing into the rest of Asia. That's home to Mount Everest, you may know. So these are the largest mountain ranges on the planet, tectonic mountain ranges. Mountains that we have in Wales, so Pen y Fan and Snowdon, they are either fluvial or glacial. They're made during the last ice age or they're carved by rivers. They are not tectonic mountains, just as a side note. So bottom middle box, any kind of explanation along these lines. How does a destructive boundary cause fold mountains? Okay, finally, this last one is a little bit more complex. Oh, no, there's an animation here that shows you how the Himalayas are forming as fold mountains. I'll show you briefly. So India is actually on its own small subplate. It used to be its own subcontinent, and there was ocean in between India and the rest of Asia. So this is Nepal and China and Pakistan over here. And what's happening is India is actually moving upwards. It doesn't want to play. That's a shame. And it's crashing into the rest of Asia and causing the land to buckle upwards along here, forming fold mountains. Okay, the last one, island arcs. So far we've been dealing with, usually, where a destructive boundary is continent meeting ocean crust. And the ocean crust is subducted because it's more dense. Sometimes you get a destructive boundary where it's two oceanic crusts meeting and they have the same density. One is still then forced down slightly, but what it creates is, instead of volcanoes as part of the fold mountains on the land, it creates volcanoes in their own line within the ocean. This animation will explain it a little bit better. I hope it works.
In this animation, we're going to subduct some ocean floor underneath the edge of a continent. And as that happens, as you know, you get an ocean trench, but at a certain depth, about 80 miles down in the earth, the subduction of the plate triggers melting of the mantle, and that magma rises, and a whole series of volcanoes begins to pop up along the edge of the continent parallel to the trench.
Okay, so this is what we've talked about already. This is the subducting oceanic crust melting in the mantle and rising to form volcanoes that are scattered in amongst the fold mountains on the edge of the continent. Oceanic to continental destructive boundary.
We call this a continental volcanic arc. The Andes Mountains are a classic example of such a system. Now another thing we can do is have, instead of ocean floor subducting underneath continent, we could have ocean floor subducting under other ocean floor. In this case, the animation is flipped around, but it doesn't really matter. You can imagine either of these in a mirror image. Same process. We're going to subduct the ocean floor underneath this other ocean floor. We're going to generate magma. The magma is going to rise, and a whole series of volcanic islands is going to pop up in the ocean parallel to the trench. You see how it's very similar to the continental situation. The only difference is that the volcanoes are popping up out of the ocean parallel to the trench instead of on land parallel to the trench. Okay, so an example of this would be the Aleutian Islands, say, or the Philippines, or the Marianas Islands in the Pacific. These are all what we call volcanic island arcs. Volcanic island arcs.
Okay, so it's essentially exactly the same process, but instead of them popping up on the edge of the continent, they pop up on the edge of the other oceanic plate. Okay, so that's our last, previous. So that's our last feature. So something along the lines of, in some cases, a destructive boundary is created where two oceanic plates meet, instead of an oceanic and continental plate. Where two oceanic plates meet, one is still forced down, and that one that is subducting will melt in the mantle to create magma that rises to create a line of volcanoes on the edge of the other oceanic crust. When those volcanoes then pop out the top of the sea, it creates a volcanic island arc. Okay, so re-listen to that if you need to write your final explanation in that final box. And then that is the end of lesson 2. That's destructive boundaries dealt with. Now, if destructive boundaries were the only kind of plate boundary where crust is being destroyed, it's being forced down and melting in the mantle, what would happen to the size of our planet? Technically, it would get smaller probably, wouldn't it? Because we're destroying crust all the time. But the size of the planet isn't changing. So something must be happening somewhere else to balance out the destruction of crust. Crust must be being created as well. So that's what we're going to look at next lesson, is constructive plate boundaries. Boundaries that create new crust rather than destroy it. So I'll see you soon for lesson 3.